Okay guys, welcome back. So in the last video I talked a situation in which I explained to you about the concept of conduction. So in this video I will be explaining a concept and a practical example in which we can find the value, right? We can calculate the value of some I'll calculate the value of theta, a practical example in which conduction is taking place. Alright, so I'll use the same system. I'll use a system. So assume that two rods are connected here, like this. Two rods are connected like this. And I'll take these two rods to be A and B. Right, A and B. So what happens is that I'll take the length of this rod to be 5 meters, length of this rod to be 6 meters, the temperature at this end to be 90 degrees, right, 90 degrees, temperature at this end to be 40 degrees, K of this value, K of this rod to be 0.2, right? 0.2. So these are just arbitrary values, right? I'm taking. So K of this rod to be 0.4, right? And the areas. This area to be I'll take as 8 centimeters square, and this area I will take it to be say something like 60, right? It was 50 centimeters square. Huge one, right? 50 centimeters square, right? So I want to find the value of the temperature at the intersection, right? So if I take the rod from consider rod A, right? I can put the now if Q the rate of change of energy, or the rate at which energy is provided, is Q by T, that will be a constant throughout these two rods because the same energy is passing through both these rods. Alright, so from A to A I can say Q by T, we can put the normal concept in conduction. Q by T is equal to K times A times delta theta divided by L. So Q by T is the same value, so K is equal to 0.2. A is equal to now 8 centimeter square. Now if you are putting in SI units, we have to convert that into SI units. So 8 centimeter squared is 8 times 10 to the power minus 4 meter squared. We will write that here. 10 to the power minus 4 times delta theta. Delta theta is now you know that this temperature is 90, this temperature is 40. So this temperature will be between 90 and 40. Now both power and energy are scalars. So to avoid getting a minus value, we have to deduct the greater value from the least value. So this will be 90 minus theta divided by L is now 5, right? L is 5. So this is 0.2 times 8 times 10 to the power minus 4 divided by 5. So that will be equal to 3.2 times 10 to the power minus 5 times 90 minus theta. So this will be 3.2 times 90 minus theta times 10 to the power minus 5. So this will be the equation 1. Okay? This will be the equation 1. So from B you can say Q by T is equal to, you can put the formula, K times A times delta theta divided by L. Delta theta divided by L, right? So Q by T is a constant because the same energy is passed through rod B as well. So K is given as 0.4 times A is 50, so 50 times 10 to the power minus 4 times 40 minus theta divided by the length 6, right? It's 6. No, I'll take it as not. I'll take it as 70, right? 70. Right? Area to be 70. I'll take it as 70. So this will be 70 times 28, 2.8 divided by 6. So that will be 12 times 40. Sorry, this is theta minus 40, right? Theta minus 40. Right? Theta minus 40. So I'll take the area to be 70. So this will be 70 times 0.4 is 28. 28 divided by 6. 28 divided by 6 is 464. So it will be 4.66, right? 4.66 times theta minus 40 times 10 to the power minus 4, right? Minus 4. Right, equation number 2. I'm sure, right? 28. Yeah. 10 to the power minus 4. Alright. So from equation 1 and 2 you can say that q divided by t is the same on the left hand side. So 1 is equal to 2. So if 1 is equal to 2, what you can say is that if the left hand sides are equal, right hand side should also be equal. So from equation 1 you can say 3.2 times 90 minus theta times 10 to the power minus 5 is equal to 4.66 times theta minus 40 times 10 to the power minus 4. So this will, you can cancel 1 here, so this will be 10 to the power minus 1, so that one is here. 3.2 times, so 3.2 times 90 is 277, 18, 288 minus 3.2 theta will be equal to 46.6 theta minus 46.6 times 40. Right? So this will be 49.8 theta. So this will be 466 times 4, right? 466 times 4, which is 466 minus 4, 6, 18. So here is 288. So it will be here 12. Right, 12, 15, 2158. So theta will be 2158, 52, right? 2152 divided by 49.8.